ScreenInventor.com.
Hi, this is Screencast 9.1, The Mole. Let us begin by considering a molecule of water. Well, it looks like it's twice as many hydrogen atoms as oxygen atoms, but in fact, by mass, water is mostly oxygen. That's what it looks like right there. If you look at the relative sizes and really the relative masses of a molecule of water, look at how big oxygen is, and look at how small hydrogen is. An oxygen atom is 16 times more massive than a hydrogen atom. It's about 90% oxygen and 10% water by mass. Since atoms come in different sizes, we have to account for that when we make molecules. You need very little hydrogen by mass in order to make a molecule of water. You need a lot of oxygen. That's what the mole is all about, adjusting for the different sizes and the different masses of atoms. A gram of hydrogen atoms, notice that that is the average atomic mass of hydrogen. It is also its molar mass. That means it contains a mole of hydrogen atoms. Somebody worked it out and found out that there's 6 times 10 to the 23rd hydrogen atoms. Anytime you use the average atomic mass, it is 1 mole of those atoms. This is because you'll need a lot of that substance for the big atoms and not very much of that substance for the little atoms. That's all the mole is really about. Oxygen is much bigger, so you need 16 grams of oxygen, its average atomic mass, or its molar mass, to have 1 mole of oxygen atoms, and that's 6 times 10 to the 23rd. That should be an exponent right there. Oxygen atoms. Oxygen is a lot bigger than hydrogen. So the mole is the SI unit for amount. Anytime you have a molar mass, which is that number on the periodic table, that is the average atomic mass, it is that many particles. You'll see that for uranium it's a really big number, neptunium a huge number, but for the little atoms it's a very small number because the atoms are each smaller, less massive. Let's apply this to make something. You can make water from the elements. You mix hydrogen and oxygen and it makes water. Balance it out and you see that you need 2 molecules of hydrogen for every 1 molecule of oxygen to make 2 molecules of water. If we do this on a massive scale, we could say we need 2 moles of hydrogen for 1 mole of oxygen to make 2 moles of water. And to do it practically, if you look up those molar masses on the periodic table, you'll see that that means 4 grams of hydrogen, 2 times 2, for 32 grams of oxygen. 2 times 16 will make 36 grams of water. Now we could actually do it. We wouldn't be wasting anything. This is pause. For some reason we've got to wait here. I think it's doing an autosave. I'm going to pause. Okay, we're resuming here. And so that's very practical. And that's what it really looks like right there. There's your 2 molecules of hydrogen. Say those 2 is 1 molecule, those 2 is another. And there's our 1 really massive molecule of oxygen. They combine like this. Each oxygen will take on 2 hydrogen atoms, and that's what your 2 water molecules will look like. And that's why you need those 2 pairs of hydrogen for every 1 pair of oxygen. We can say that 2 moles of hydrogen molecules combine with 1 mole of oxygen to make 2 moles of water. The really practical part is that we could say that 4 grams of hydrogen react with 32 grams of oxygen to make 36 grams of water. And that's a little bit about the practical utility of the mole.